Hello guys, in today's video we're talking about the inter-blockchain communication protocol. So as you all know, what blockchains are, they are distributed ledgers that you can build things upon and all that. So the first of them started with BTC. It became a simple store of value, and it has limited scripting that you can do with it with the fourth programming language. The next that came on the scene were clones of BTC. We have the Litecoins that increase the supply. We have the Doge coins of the world, the peer coins and all that. So, but if you needed to do something, you needed to create a blockchain for itself. So that is where the concept of Ethereum comes in. How do we extend the programmability of the underlying blockchain to support a lot of use cases? So Ethereum came on the scene. When Ethereum came on the scene, we have a lot of things now, but we run into scaling issues because the more people come into the network, the slower the network becomes and the higher fees people pay. So when I want to deploy an application, for example, this is my application, this is another application, this is another application. Maybe my application has 10,000 users, another person has 10 million users. So my users will be forced to pay the same fees as the one of 10 million people because that's just the way to do it. That is where the modular thesis actually comes in. So the modular thesis says, why not we build a lot of blockchains to scale to different needs, and then we connect these things together. So the Ethereum is going to that route. Cosmos has been going into that route for a long time, but let's see what it does. So what is the inter-blockchain communication protocol? So it's similar to the TCP/IP, if you are aware of the internet, a protocol for transmission of packets on the internet. So what is the IBC all about? The IBC is a communication protocol for authenticating data transmission and for relaying this data. So let's explain what that means. So any state machine, a state machine could be a distributed ledger, it could be blockchains, distributed systems, it could be any kind of machine. What they have to do is they have to pre-agree. So let's take for example, this is a blockchain and this is another blockchain. So they have to pre-agree that they want to communicate. So they have to pre-agree things like, what do we communicate within ourselves? They have to pre-agree on things like, what version of software do we use? They have to pre-agree on things like, how do I recognize that you are the one sending the message? So it's like, let's say for example, two nations. This is a nation, this is another nation. So they have to they want to open, for example, their borders to each other. So they will be, okay, how do I know that it is you or your person that is sending so packet from here to here? So that's where the IBC comes in. So the IBC is like the postal service. So you take your letter and you says, okay, I'm going to send this message, and then it takes this message to the destination. So you communicate, and then they communicate. So for that to happen, you have things like communications and all that. So let's talk about the IBC. What makes up the IBC? So the IBC consists of two layers. So there's a transport layer, and then there is an application layer. So the transport layer consists of the light client, the connections, the shiners, and then the ports. So let's explain what are light clients. So light clients, if you have some understanding of blockchains, blockchains, they basically help with storing data, validating blocks, and then storing these blocks for a long time. But light clients are basically the lightest form of node on a blockchain. All it does is to read the headers of the particular chain. So it does not have to store everything. All it just keeps track of is the ID of whatsoever transaction, the data and everything that comprises the transaction. It does not concern. So at the very it's the most minimalistic form of storage for a node. The next thing is connections. So like I said, when two blockchains have pre-agreed on the terms of communication, they will have to open channels to say, okay, this is channel, and the channel will have an ID and all the parameters, and says, okay, communicate between this and that. So when this channel opens, the clients at this other end, or at both ends of the blockchains, are what we call connections. and then we'll talk about things like ports. Ports are kind of modules you can use in connecting. So when a channel is open between two blockchains, they will have what we call the relayers. So the relayers, anybody can run a relayer. They basically listen for a request message and they send it back to the send it from the source to the destination chain and says, okay, so person wants to transmit this, allow it to go through. Now the next part of the IBC is the application layer. So the transport layer defines specifications around what is to be communicated, who do we communicate with, and other parameters. The application layer defines what and what is obtainable when two blockchains can communicate. So that's where we'll talk about things like standards. So standards, we have the ICS, the interchain standards of, okay, this and this are permitted under source security. We have different standards. There are many. We have ICS 20 that deals with the transfer of fungible tokens. We have the NFTs that is dealing with interchain NFTs, but it's still in development. We have cross-chain validation, which deals with how a chain can provide security to another chain, and that is the foundation between the replicated security, which was initially called the interchain security, but it's now called replicated security. So what that means is that you have a big chain, and then you have another chain that is launching that is a smaller chain. That chain can borrow security from the bigger chain. And then we talk about things like interchain queries, how you can query what is going on in another chain and all that. And then we talk about interchain accounts where you can perform actions as if you're on online chain. So you are on this chain, you can perform actions like staking, voting, etc. on this chain, whereas you are using this chain. So we'll talk about the application layers. Now you might be asking, how secure is this thing? You've heard of stories like the Roni bridge attack, talk about the Binance bridge attack, we talk about the things like the Harmony bridge attack and all that. So what are the security guarantees? So the security guarantees is around these two things. First is IBC says trust the chain, not the bridge. So when you relay, when you establish connection between two blockchains, normally in this case we had bridges, like we'll talk about that. So bridges are like, we have like likes of hop protocol and the rest of them that produces cross-chain bridging and all that. Now once you trust that, what happened with the Nomad hack? So the Nomad hack, they hacked on Epmos, they hacked the Nomad bridge and there was an exploit. So what this platform is saying is that no, don't bring a third party between us. No, we define our connection. So we define the connection, we define what to allow and all that. So it's like two nations. They define what sort of material is to go through themselves back and forth, and who is to carry it. That's what who is to carry it. They will have things like shiny IDs and the rest of them. So there's nothing like you're bringing a third party to say, okay, I'm the one that will be going between back and forth. No, this guy can come, this guy can come and all that. So that is where a lot of cutting to do. So that's where say trust the chain. So trusting the chain, you just need something like that, the light client, because this chain runs consensus. It stores blocks. So when you rely on third-party attack, third-party bridges, you are impotent based on the answer that they give to you. So but when you run light clients are always up to date to the latest happening on that block. So the next thing is, okay, what do we do when a relayer or a light client submits misbehaves? You can isolate them, and that is where the IBC is designed in such a way that it prioritizes security over liveness. So in the case where there is some shenanigans going on, or what it will simply do, it will simply freeze the asset and then investigate the stuff and then punish accordingly those who are misbehaving. So you might be asking, if you're talking about the interchain transfer, for example, the ICS. So for the ICS, when a token leaves the source, for example, to a destination, the token has three data on it. The first, it has a data that specifies where it's coming from. It has data from where it's going. And then it has specific data, mental data, around that transaction that is inside the transaction. So you can look at a token and say, this token moved from so to so at some point. So in the case of security issues, you can be able to see and pinpoint that this is what actually happened. Okay, so let's talk about before IBC. Before IBC, we saw the problem that communication faced. So before we talk about IBC, let's talk about why IBC. So first is the issue of interoperability. Now interoperability here, we're talking about no barriers. We see that when we start creating different blockchains, for example, we have the likes of Ethereum, Polkadot, this, that, and that. There's fragmentation, there's barriers. You as a developer, you want to build, you are considering, where do I build? Now when you build your project here, there are users that are not here who will be deprived of your product. And when you build here, there are users who are not here that will be deprived of your product over here. So there is the barriers. And then there is the issue of custodians. So custodians are the ones who come in the middle. So it's like you send an asset, they process it and bridges and all that, and then they say, okay, meet it on the correspondence and all that. And then there is the issue of how do we transfer without platforms like centralized exchange. It's very possible with protocols like the inter-blockchain communication protocol. And then it's very, very necessary in the when we're dealing with the multi-chain modular thesis. So it's been 2 years now that since the first IBC transfer was initiated, and over $178 billion is under management, and over 274 options are actually live. So you might be asking, who is using the IBC? A lot of chains on the Polkadot network. We have the likes of Osmosis, we have the likes of Juno, and so on and so forth. So they communicate back and forth between themselves. Now, where is the next stage of development? So I'll talk about two things: the implementations that are going on between Cosmos and other chains, and then also talk about I'll reference you to a document. We'll talk about some of the upgrades that will come, things like shiny upgradability and the likes of it. So IBC has gone beyond Cosmos. So platforms like the Babylon chain, they are trying to bring Bitcoin security to Cosmos chains. Now, the issue here is, how do we make proof of stake networks more secure? Because there are some inherent risks with proof of stake systems. So the Babylon chain, I will talk about that more later. We dive into that, and there are many chains that are integrating the Babylon chain module for harnessing Bitcoin security to IBC chains. The next is, how do we connect Ethereum to Atom and vice versa? So there are platforms like Electron Labs and Polymer who are doing that. And then we have the Centurion Bridge that is trying to connect the Tosama and the Atom ecosystem. And we have the Landslide Network, is a subnet on Avalanche that is trying to connect the Avast network to the Atom network. Then we have the likes of inter-chain roll-up communication. We have the likes of Saga that have over 270 projects building on it. We have Eclipse, Celestial, Dimension that are trying to build roll-ups and have these roll-ups communicate between them using IBC. And then you have Pen or Brown, a non-Cosmos chain that is integrating Cosmos. And then we have cross-chain NFTs and the rest of that. Now, one of the things you have to understand is that when you are building with the Cosmos SDK, you have IBC as a module that is enabled. However, even if you are not building with the customer SDK, there are ways you can integrate. There are several implementations like in Rust and Go and other that you can use to integrate IBC into your stack. So I hope this video has been able to give you some understanding about IBC and the way forward. Thank you very much for being my guest.